Welcome to another episode of Total Space Network. Today we are taking a deep dive into SpaceX's Dragon vehicle that recently flew astronauts to the International Space Station. I'm Mikko, your regular host here, and with me is...
I'm Rich L-B, host of Becoming Multiplanetary, and we normally air on a Monday. It's another Total Space podcast show, and I'm going to be here to talk with Mikko about the Dragon, and passing on to my other co-host.
Hey everybody, I'm Kage. I am also one of the co-hosts of Becoming Multiplanetary, and excited to talk about some interesting SpaceX technology.
So, did you guys see the Crew-1 mission earlier this week? I watched it live at 2:27 a.m. Finnish time, despite having to work the next day. But I'd say it was quite worth it.
Yeah, I also set an alarm so I could make sure that I got up in time, since I'm also over here in Europe, and it was definitely worth waking up for. It was a really exciting mission to watch. I missed all the introductory things of the suit up and the SpaceX ninjas and everything else, but at least I got to see the launch and everything else. So it was right. It was great.
So when I joined into the stream, they were closing the hatch for the first time, but then they had to reopen the hatch because there was some kind of seal issue. They noticed a pressure drop, so they reopened the hatch, and after that they checked it out and resealed it, and then it was all good. And I saw it from there. I was in the stream until after, I believe it was once they'd reached orbit. I had to come off because I had to do other things, but no, watching the launch was absolutely amazing.
Yeah, definitely. So before we go into the Dragon's details, let's go over how they were born. So most of you probably already know the story, but Space Exploration Technologies, or SpaceX, is a private corporation founded back in 2002. After 3 failures, they got their Falcon 1 rocket into the orbit in 2008, being the first liquid-fueled private rocket to reach orbit. And Falcon 1 had only one flight after that, before SpaceX decided to move on to a bigger rocket. And SpaceX had won a contract already in 2006 to demonstrate cargo delivery to the ISS. This started the development of the most operational US rocket, Falcon 9, along with a cargo capsule named Dragon. SpaceX got just under $400 million to develop the vehicle and the capsule, thus saving NASA possibly billions of dollars. And in December 2008, SpaceX had already been awarded CRS contract, the Commercial Resupply Services, that was worth $1.6 billion.
And that would have been when they were starting to do runs with the cargo Dragon first, wasn't it?
Yes, exactly. In December 2010, SpaceX became the first private company to successfully launch, orbit and recover a spacecraft. Dragon had just 2 orbits before it re-entered through the atmosphere. Before that, this was only achieved by government agencies.
So quite a big milestone for them then.
Yeah, definitely. Their second demonstration flight was in May 2012. That marked the first time a private company had berthed with the ISS.
Kind of lost track of the amount of milestones, the firsts that SpaceX has done. We've got first commercial program to dock with the ISS, the first company to reuse first stage boosters, the actual boosters, if you're not including like the solid rocket boosters of the shuttle, the first commercial crew program to launch humans on commercial flights to space. There's a lot of firsts that they've done.
Yeah, you can't remember them all. But let's go into the details of the first Cargo Dragon capsule. Original Dragon version 1 had a dry mass of around 4.2 tons, while being able to haul about 6 tons to the orbit and bring 3.5 tons back to Earth. The capsule actually has been already retired. When do you see successful spacecraft being retired after 8 years? So the whole CRS contract has been very successful, originally being 12 flights that was extended to 20 flights, and last flight of Dragon 1 was earlier this year, was the CRS 20 mission. Even though it was quite successful, there was one launch failure in CRS-7 that was due to I think it was the upper stage of the Falcon 9. And many of the CRS flights were done with a reused capsule, even up to 3 times.
It was certainly a workhorse whilst it was in operation. It got the job done. It got the cargo needed to the ISS quite a few times. And then it was a case of, once they bought Crew Dragon out, they just retired it and just decided to use that instead.
Yeah, that's the Dragon version 2. There's 2 separate versions for cargo and crew. And for cargo, they already have the CRS-2 contract that I think has at least 6 missions on the calendar. And it's basically the same as Crew Dragon, but without launch abort systems and life support. In 2014, SpaceX's Crew Dragon concept was awarded $2.6 billion for a transportation service vehicle, while Boeing got more for the same deal to fly Starliner. And they haven't flown yet, at least successfully.
I think there was a tweet that went up recently, though. Someone actually gave a tour of the facility where the Boeing Starliner was being developed.
I didn't see that.
What I'll do is I'll send you a link and also include link in the episode description as well, because I'm pretty sure that's going to be quite interesting to add.
Yeah, and another news bit about Starliner was it being delayed to 2021. Originally, Crew Dragon was supposed to actually use the in-flight abort engines to land after a flight, but that was actually eventually cancelled because of the certification process would have just taken too long, and legs coming through the heat shield didn't help. Actually, the Red Dragon was based on this one. I think there was a Red Dragon that was supposed to go to Mars, but when the Starship came along, it just replaced that plan. Crew Dragon is quite a bit heavier than its predecessor, weighing at around 9.5 tons. The cargo configuration stayed about the same, getting around 6 tons to orbit and 3 tons back. But due to heavier weight, they also added a 4th parachute. Crew Dragon is able to carry up to 4 crew members, and this is down from the original design of 7 people, and the extra space got used by seats that are adjusting for the splashdown, and Gwen Shotwell actually confirmed this in a NASA conference.
Talking about the Crew Dragon there for a minute, why don't we have a chat about the MMH, the elephant in the room, as it were? So the Super Draco boosters, we know as the abort system, being fueled by MMH, monomethyl hydrazine. I understand how the fuel is very efficient and it is needed for the thrust required for the abort motors. However, when I was watching the Demo 2 splashdown and seeing Bob and Doug being hoisted out of the water, they had to wait ages, and I mean absolutely ages, for the MMH to clear first because it's that toxic to humans. Does anybody know if they happen to have a plan to replace the MMH with something else in the future?
I mean, I don't think they will replace it for the current Dragon. They actually had a plan to start a flushing procedure earlier, just after splashdown, so next time they wouldn't have to wait. But of course, NASA has been developing some green fuels, and we actually have talked about those in the space update.
It's also worth mentioning that one of the reasons why they use MMH is it's incredibly stable. It also has no real problems with the dramatic temperature differences that happen when you're facing the sun and in the shade of the sun, where temperatures fluctuate by, I think, a couple hundred degrees centigrade almost. It tolerates that without any problems, and it's also incredibly reliable that when you mix MMH with an oxidizer, it ignites. No questions. Pretty much always works. I'm actually not even aware of any times where a hypergolic fuel mixture like that failed to ignite.
So let's talk about Dragon's heat shield. The heat shield is made of in-house material called Pika-X that SpaceX developed based on a NASA precursor, and the heat shield was actually designed to withstand the entry from the moon, so making it reusable was fairly straightforward. currently Dragon is planned to do 5 missions per capsule at least.
So the heat shield there, is it the same material as the hexagon heat shield mounts that we see on the side of the starship? Is it the same Pika X material?
No, it's not the same material. Pika X is ablative heat shield, whereas Starship's heat shields won't ablate.
Okay, so it gets rid of the heat via ablation. Got you.
Yeah, and it has enough material to do at least 5 re-entries before it's expended.
It might also be worth mentioning that the heat shield was, I think, one of the biggest reasons why the SpaceX Dragon, which was mentioned earlier, as well as the propulsive Earth landing Dragon concept were abandoned, because of those concepts originally had 4 little legs that would pop out through the heat shield, and that apparently proved to be a quite significant engineering challenge that SpaceX ultimately decided just wasn't worth the investment.
Yeah, definitely, because getting it certified reliably would have been quite difficult.
To quote Elon, about in terms of the design process, if it's long, it's wrong. If it's tight, it's right.
And the best part is no part.
Exactly.
Good slogans. So the Dragon has an in-flight abort capability, and it's able to abort from pad to orbit, making the vehicle very safe compared to Space Shuttle, for example. I think the numbers were around 1 to 80 for Space Shuttle and 1 to 276 for the Crew Dragon, for a loss of vehicle or loss of mission. And the abort engines are called Super Dragos, and there are 8 of them. And the engines are integrated to the capsule. In an unlikely scenario of failure, the crew can safely abort to one of the specified landing sites or even to orbit.
Yeah, I mean, you hear it during the launches. So you've got the various dropout zones. You've got up to Newfoundland, and then you hear the famous call, onto Shannon, which is just off the coast of Ireland. And I believe that's the last point where they can abort back down to Earth before having to abort to orbit.
Yeah, I think so too. And the abort to orbit, I think that was only for the last second of the flight. So when the Dragon reaches orbit, it uses the smaller Draco engines to control the vehicle. And they do use the same fuel system. And the Dragon also has a trunk section, and that can be used for unpressurized cargo. And the fins that it has are meant for stabilizing the capsule in an abort scenario.
I might have missed a few launches, maybe, but as far as I remember, I don't think they've ever used the trunk to carry unpressurized cargo yet, have they?
Probably not on the Crew Dragon. But on the earlier Cargo Dragon versions, they at least used it for bringing the international docking adapter to the International Space Station.
Right, yeah.
So the abort engines were first tested in 2015 for a successful pad abort test. Early 2019, SpaceX conducted the DM-1 mission, which was the first demonstration mission of the new capsule, uncrewed of course. The test was completed smoothly from launch to landing without major issues, but after the mission there has been quite a few problems. Biggest problems have been with the abort engines and parachutes. While the DM-1 capsule was being static fired for in-flight abort test, the capsule exploded, and the reason was found to be the titanium that exploded when in contact with fuel. And it was fixed with burst discs that only allow fuel to pass through when the engines are actually fired and need changing after use.
Talking of burst discs, they're the real MVPs for SpaceX at the moment after SN8.
Definitely. There was also another problem with parachute. SpaceX needed to develop the new material called Xylon to replace the nylon straps in some of nominal case. Those could have been fragile. After Jim Bridenstine got a bit fed up with the progress, SpaceX did tons of testing with parachutes, and finally in January this year, the in-flight abort test was performed. This featured a flight up to Max Q, where Falcon 9 engines were shut down, which triggered the automatic abort function of the capsule, and capsule escaped far from the rocket that was exploding under the aerodynamic loads. This must have been one of the coolest intentional explosions ever. So after the in-flight abort test, next up was the DM-2 mission that included 2 astronauts, Bob Behnken and Doug Hurley, and they flew to the ISS on May this year. I still remember how nervous I was watching the launch, but I felt safe right after the staged separation of Falcon 9. And it was really an unforgettable night with Felix, DJ, and Marcus.
I mean, the whole Crew Demo 2 mission itself was just a roller coaster of emotion for me. It's an extraordinary event that it was, 8 years or 9 years since the last time humans had flown from US soil. Even more than that, it was the first time that a private company was able to achieve something like this. Even more than that still, that a company was able to achieve it by breaking all the molds for decades before it. I mean, the whole thing, not just the event, but everything that led up to it is just extraordinary. I mean, the whole thing was a roller coaster of emotions for me. Really,
I gotta say, the one moment that really got me choked up was when Bob and Doug were saying bye to the wife and kids in the car, like waving through the windows. That really got me.
Okay, serious question time. Do you think that when they return this time, they're going to have the same issue with boaters? I really do hope that they get a wrap on that, because holy cow, was that was a cluster. Other word here that I won't use.
Well, they've said that they're going to have a bit more of a presence to discourage that, but I don't know what they've actually worked out. We're not going to know until we see them splash down.
Alright, so the astronauts stayed on the ISS for 2 months before completing the mission with nominal splashdown. The mission was near perfect, excluding some rogue boaters and slightly more burned heat shield than it was supposed to be. And the heat shield got an upgrade for the Crew-1 mission, along with barometric sensors and full duration solar panels. And finally, the Crew-1 mission launched this week with Mike Hopkins, Victor Glover, Shannon Walker, and Soichi Noguchi. Launch of the Crew-1 looked perfect, even though there was a couple of mishaps on the way, but it's gonna look routine at some point.
So one of the things I am in absolute awe with the Dragon right now, and they mention this quite frequently on the launch coverage, is the fact that Dragon does have the capability. You could put, I don't know, just your average Joe off the street in a Dragon capsule, and it can fly itself between Earth and the International Space Station. The whole thing can be done automated via the software. And that brings me to the software and the hardware of the Dragon capsule. Now some of the stuff that goes on in there is quite amazing. So one of the things that I want to talk about initially is the difference between a radiation hardened design and a radiation tolerant design. Now what this means is when you were working with the likes of the space shuttles and whatnot, they had radiation hardened designs, and when you work with the radiation hardened hardware, you're very limited to what you can do in terms of programming. So the only programming languages that the radiation hardened hardware supported is Original C, Ada 83, and Ada 95, and they supported some real-time Java implementations for the 32-bit applications, and only some. So these software languages are quite difficult to recruit for because not a lot of people know them, and the difference being with the Dragon is what they've done is they've just literally taken hardware you can buy off the shelf. Like you can go to a store and buy some AMD Ryzens or Intel processors or what have you. They're just using off-the-shelf technology, which means they have access to programming languages like C++ and can't remember any of the others they use off the top of my head right now. But it allows you to do so much better things. And the OS they use, by the way, is a version of Linux. The readouts that you see uses a piece of software known as LabVIEW. So these are all things that I learned just recently, actually, and it's all very fascinating. Kage, I know this is right up your street.
Yeah, thank you. So yeah, going back to what you were talking about with radiation tolerant and why SpaceX is able to use off-the-shelf hardware for this. So if you look at radiation hardened technology, or hardware rather, it's built to actually resist what are called bit flips. And what that is when you have cosmic rays coming in and they hit electronic components, especially on memory modules. Depending on the memory module, you might have memory arranged in what are called banks. And in those banks, you have certain chunks of memory, which are stored in your typical ones and zeros, or rather a powered high and a powered low state. And so what can happen is that when you have cosmic rays come in, it would actually end up hitting one of those memory banks and can flip one of those bits so that what was set to a 1 or an on state is now set to a 0 or an off state. And when you have especially things where there's very tight memory constraints, one single bit that's flipped could corrupt the entire data stream. And so with radiation hardened hardware, it would be designed in a way that it would actually prevent radiation from penetrating that hardware, whereas radiation tolerant hardware is where it actually has a series of redundancies in place so that even if you do have a bit flip scenario, there is a sequence of events where all that hardware does a kind of like a data election, I guess you could say, where they compare their data across all the different units to determine what's the most likely data output that's supposed to be here, and also they check it against things like certain threshold tolerances. So if multiple devices failed, if multiple memory banks failed, what should it actually report, and is it within or out of those bounds?
Yeah, and they have the capability to work even if all three are affected by the radiation through use of parity bits. The other thing I was about to bring up, by the way, it's not quite a bit flip scenario, but an example of what happens when coding goes wrong. I don't know how familiar you are with the Ariane 5 launch, when during the launch, it thought it was veering off course, so it did a really hard turn to the left, and it broke up midair. And the reason for that happening was because they were trying to stuff a 32-bit integer into a 16-bit variable effectively, and it truncated the value, causing that error.
Yeah, I think SpaceX actually has 3 computers, so double redundancy.
So let's talk a little bit about the actual hardware and software that runs, especially the Dragon capsule, but this is also in a lot of ways true for the Falcon 9 rocket itself. So with the Dragon capsule, as Mikko mentioned, there are 3 flight computers that are in operation, but each of those flight computers also has additional layers of redundancy, and there are, as of at least 2012 data and some information earlier this year in a Ask Us Anything Reddit with SpaceX engineers, about 18 other systems on board that also use triple redundancy. So that brings the total number of processing units, I guess you could say, to 54. And that's just for the Dragon capsule. Then if you also look at the Falcon 9, it does very similar things. So it has at least 30 processing units, probably a lot more. And in fact, that number probably fluctuates between each and every Falcon 9 rocket, because it's important to note that one of the things that has made SpaceX so successful and so quickly successful is that they follow, rather than a waterfall design process, which is typical from NASA, where you control all the variables and you do a lot of research and analysis on every single potential variation that can come out through your project. They instead go for more of a modern software design paradigm called agile development or iterative development, where they'll design something and get to maybe a minimum viable product, also called an MVP, test that, find out what fails, research what failed, and then build again, and then just do that over and over and over again until they finally get it right. And they still do that to this day. They do that with pretty much every Falcon 9 rocket, at least to minor degrees where they try little different things here or there. They might make little adjustments to some pneumatics thing here or some software there, but they're always improving and changing them. And it's entirely possible that the amount of redundancy that they have in place, the amount of processing units that they have on the Dragon and on the Falcon 9 is anyone's guess except for the engineers within SpaceX. Who knows how much what kind of hardware they're using in there. But one thing that is known, at least from Q&A sessions with engineers at SpaceX, is that they are using effectively off-the-shelf parts. They're using hardware that you could probably end up pulling one of the main computers out of a Dragon capsule or a Falcon 9 rocket, put a ATX power supply on it, throw a graphics card in it somehow, and play some Doom Eternal on it. Really, it's just off-the-shelf x86 hardware. And that's absolutely fascinating that when you look at especially the radiation-hardened hardware that existed for like the space shuttle and for many other, especially human-rated spacecraft, you would have to have very specialized testing components in order to actually produce your software on it and run tests on it. So some of these computing units would cost in the order of millions of dollars in order to produce, and then you'd only have a few of them available. So if you wanted to do any kind of software testing on them, you only had a very limited amount of hardware that you could test it on. Whereas with SpaceX, you can actually run the software in a virtual machine. It's actually, give me 1 second, I'll pull it up. So according to SpaceX engineers, let me get their names actually. So there was a Reddit Ask Us Anything back in, I think this was in May of this year, with Jeff Dexter, who runs flight software and cybersecurity at SpaceX, Josh Sulkin, who is a software design lead for Crew-Dragon, Wendy Shimada, who manages the Dragon software team and works on fault tolerance and safety for Dragon, John Dietrich, who leads the software development effort for Crew Demo 2, Sofian Hanadi, I'm so sorry I'm butchering that name, who works on the Crew Displays software for Crew Demo 2, and Matt Monson, who works on Dragon and is now the lead Starlink software engineer. So one of the things that's really interesting about the software that they use is that, again, it's all off the shelf. It's C++ and JavaScript and HTML.
Right, and going back to earlier when you were talking about the 3 flight computers, now think this all happens automatically. The astronauts don't need to do anything for this, right? Let's say we get the 3 flight computers to do a calculation. We're calculating our current trajectory, we've just entered orbit, and we're doing a trajectory calculation to the ISS, calculating delta V and whatnot. If those 3 flight computers do the calculation, and one of them, due to a bit flip error, gets a different number, what will happen is the other 2 flight computers will notice that the 3rd flight computer had an error, and the other 2 will force reboot the 3rd unit. And this all happens in the background automatically. The astronauts don't have to do anything at all. Whereas with the shuttle, there were so many circuit breakers in place to isolate systems and reboot computers and whatnot. And now, because of advances in software, it all happens automatically. You know, how crazy is that?
One of the things I think that's most fascinating about it is that not only is it fully autonomous, but it really is just so much off-the-shelf hardware and software, and they use a lot of open source. I mean, one of the things that we always love to see is that kind of over-the-shoulder look of the SpaceX astronauts. I guess they would be NASA astronauts in the SpaceX Dragon capsule, looking over their shoulder when they're changing the displays and just kind of cycling through all those. And one of the things that's incredible about that is that display is Chromium, as in one of the most popular web browser engines in the world today. They effectively use that for their display. Granted, now everything that lies underneath it, the flight software, the systems that are used for flight controls and stuff like that, those are using much more specific hardware and software, very fault-tolerant microcontrollers and things like that, and they use very fault-tolerant underlying software written in C and C++ for the flight software. But what you see is essentially fairly off the shelf. It's Linux with some additional things. It's Chromium and I think it's kind of like React web library. They roll their own for a lot of things, but it sounds like they might use a variation, an in-house variation of React. Regular old HTML, Java, CSS, JavaScript, CSS. It's just, it blows my mind, absolutely blows my mind that when you look at all the very specifically engineered hardware that has existed throughout the entire space industry. I mean, look at, for example, the flight computers that were used for Saturn V. Those were literally hand-woven core memory modules where they had people that would actually sew the copper wires in that. And nowadays, with SpaceX on Falcon 9 and the Dragon capsule as well, it's no different than your laptop, really, or gaming computer. It's just unbelievable. Yeah, and one of the things about that is that when you're working with things that are like radiation hardened, I mean, let's take, for example, the James Webb Space Telescope. That, when it eventually launches, is going to be running hardware that is, at that point, probably at least 15 years old. One of the big reasons for that is that it has been so thoroughly tested to be absolutely as fault-tolerant as conceivably possible. And they don't have enough room on a telescope like that, for example, to do something where it's radiation tolerant versus radiation hardened. And so when you're working with hardware that is radiation hardened, that's something that it takes years of certification and testing and design and everything else that goes into it in order to get it to that point. And by the time it's, flight certified, or especially human certified, years, maybe even a decade or more has passed.
Well, actually, you talk about that. There's actually a discrepancy like that right now. So we're talking about radiation hardened and radiation tolerant. There's actually a decade gap in the level of technology between the two. Like, the radiation hardened stuff is 10 years behind the specs of your radiation tolerant, which is basically off-the-shelf hardware, like Kage said.
That's really the beauty of SpaceX's iterative design, that work on going at just a phenomenal speed in comparison to what practically all the rest of the space industry goes at, that rather than spend all that time in that kind of a waterfall design aspect and taking their time to control all the variables and test and make sure that everything is absolutely perfect, and by that time probably outdated compared to what else is around them, they just pull stuff out of what's currently available, iterate on it, build, test, fail, study, build, test, fail, study, build, test, succeed. They really stay ahead of the game with that. One of the things I'm really kind of curious about is, what else can the space industry learn from this approach? How can others even take this and build on that, as it were, to also become iterative and go for more of a fault-tolerant approach rather than a fault-tested and absolutely certified approach? Oh, I could probably go on for days about it. It just absolutely fascinates me. But no, I think actually what would really be great is maybe another AMA, if any SpaceX engineers are listening, hint, hint, maybe another Reddit AMA to ask about where has all of that gone in the past 5 months or so. Because, they move so fast that what they talked about in the Reddit AMA, and we'll make sure to link to that in the description of this podcast, there might be so many dramatic changes that have been made in just the past 5 months that it might not even be anywhere near the same anymore.
Well, if you think about it, every time they launch, they learn something new. So there's probably a revised update every time they launch. Well, when you're developing software, you can tag it as a branch at that point. So if you've got a stable version, simply tag the subvert, the whatever source control you're using, and then keep developing it, SpaceX actually mentioned that if you've worked in the game development industry before, you're actually a perfect fit for them, because when you work in the games industry, you have to work to memory constraints and some bit constraints as well. But because of this, you're actually a very good candidate to become a software developer for SpaceX. So if there are any game developers out there that are looking for work, why not, look at SpaceX.
Thanks for listening a deep dive on dragons. Remember to follow us on Twitter, YouTube, and your favorite podcast platform. And I've been Mikko, the host of Deep Dive Fridays.
I have been Rich L-B, co-host of Becoming Multiplanetary. I'd like to say thank you to Marco, Susie, Framrick, Gio, and Jishwan and Sebastian for all supporting us on our Patreon. If you too would like to support us on Patreon, you can find us at totalspace.net/Patreon. Nice handy redirect, thanks to Kage. And speaking of Kage,
I am Kage. I am also one of the co-hosts of Becoming Multiplanetary. Thank you all for joining us for this deep dive session about dragons. Yeah, check us out also on Twitter, twitter.com/totalspacenet, and I hope you enjoyed this episode.